I am deeply honored to have been invited to give the 11th annual Robert Krane Lecture at the SMSNA. I'm deeply touched. I probably want to go through the discussion first and probably take 1 minute at the end to give brief tribute to Dr. Robert Krane. So it's befitting that the first slide in this discussion is a paper. The first author is Dr. Robert Krane with Dr. Goldstein and Dr. Tejada, where they proposed a real interesting model on the overall mechanism of erectile physiology and going from tumescence to erection, and what are the key players in this mechanism. Not only that, they put a hypothesis of what might be some of the molecular factor that plays in this process. So that model has been adopted by many basic researchers throughout this country and throughout the world, including our laboratory at Boston University School of Medicine under the leadership of Dr. Krane, Dr. Goldstein, Dr. Tejada, and many others. So I'm showing this simple slide taken from a review by Dr. Tom Liu, where it suggests that some of the molecular mechanism involves the parasympathetic nerves acting on increasing the expression and synthesis of the neural nitric oxide synthase, which then can act on the vascular bed and the cavernosal artery, smooth muscle, and others, and cause vasodilation in addition to the endothelial nitric oxide synthase, which actually can do similar effects on the trabecula. Taking this model, the only reason I'm showing it, there's many, many molecular events that take place to go from flaccid state to erect state, and this is a very complex process, requires many key players. I'm not going to focus on many of these key players. I'm going to just put the question forward, because this is the question is, does testosterone play a role in erectile physiology? And if testosterone does play a role in erectile physiology, can we demonstrate at the basic science level how it affects these various components that are important to modulating erection? So just to summarize, quite a bit of literature in a very basic slide is that testosterone modulates the expression and activity of neural nitric oxide synthase. It also modulates the expression and activity of the endothelial nitric oxide synthase. It actually modulates the nerve fiber. It actually affects the trabecular smooth muscle content and contractility, and also affects the connective tissue matrix, in addition to regulating phosphodiesterase type 5. So testosterone really regulates most of these components that Dr. Robert Krane and his colleagues have put in that model, which became framework for all of us in pursuing basic research. This is just a simple map, what I mean with how testosterone might regulate these various components. Testosterone, either directly or by conversion to 5-alpha dihydrotestosterone, binds to the androgen receptor. And binding to the androgen receptor in the benign tissue, it will modulate the expression and activity of the neural nitric oxide synthase, endothelial nitric oxide synthase, and phosphodiesterase type 5 as enzymes that play a key role in this physiological process. But also testosterone is really important in maintaining the structural integrity of the cavernosal structure by maintaining not only the nerve fibers, but also the trabecular smooth muscle, and also modulating the connective tissue matrix and elasticity, and also preventing adipogenesis in the penis. So what I would like to start is just look at the effect of testosterone from basic science aspect on the neural nitric oxide synthase. And this data shows that if you take the major pelvic ganglia of the penis, you can see that castration reduces the expression of neural nitric oxide synthase, and testosterone treatment restores this expression. The slide on the right shows that the NADPH diaphorease, which represents part of the nerve fiber network, co-localizes with the nitric oxide synthase, so this is really the neural nitric oxide synthase. Also, testosterone regulates the endothelial nitric oxide synthase in the corpus cavernosa, as well as the neural. And you can see here from this data is the intact expresses quite a bit of the expression and activity, but castration reduces this dramatically. Testosterone replacement or testosterone treatment restores the expression and activity. This is also data where they did not give testosterone, but rather gave a 5-alpha reductase inhibitor to inhibit the 5-alpha reductase. And you can see lane A1 and A2, this is the control animal. Lane B1 and B2, that's the animal that were treated with finasteride for 16 weeks. And you can see that 5-alpha reductase, which is the conversion of T to that, is required to act on the receptor, results in inhibition and expression of the endothelial nitric oxide synthase. Finally, I want to just show this last slide on the nitric oxide synthase. Not only the expression of the protein per se, but the activity of nitric oxide synthase is enhanced by treatment of testosterone and inhibited by castration, and also inhibited by the 5-alpha reductase inhibitor, finasteride. Now I want to just show 1 or 2 slides on the phosphodiesterase type 5 inhibitor. And as you can see, BDE is very important because it regulates the cyclic GMB content in the corpus cavernosa. And testosterone actually regulates this enzyme, and castration reduces the expression and activity of this enzyme. Castration reduces the activity of this enzyme, testosterone treatment. You say, why an enzyme that hydrolyzes cyclic GMB is regulated by testosterone the same way it regulates nitric oxide synthase? And at that moment, although I don't want to elaborate, think about having a car where you only have a gas pedal but no brake pedal. So I think testosterone regulates these both key enzymes because you want to maintain homeostasis. And if you have no regulation of BDE5 and only you regulate the nitric oxide synthase, you may end up with some predictable outcome. There's data from Dr. Abdulmaged group showing that, similar to what we showed, that testosterone is really important for expression and activity of the phosphodiesterase type 5. Now I want to just show a couple of slides on that testosterone is important for the nerve network, for the nerve fiber network. And the first piece of data is from Dr. Tom Liu group. It's a really nice study done in 2003. And as you can see, on the left side is the dorsal nerve from intact animals, and on the right side is the dorsal nerve from castrated animal. And you can see the myelination of the nerve is decreased by castration, suggesting that testosterone is critical for maintaining the dorsal nerve fibers. Data from our laboratory shows similar, this is the cavernosal nerve, not the dorsal nerve. You can see in the very far left is the control, the middle is the castrated group, and the very right side is the animal which were treated with testosterone. And you can see also again, the degree of myelination is decreased by castration and it's restored by testosterone treatment. Now I want to switch to the last component, which is the trabecular smooth muscle. And we've published some data, which is everybody else published similar data, so they are congruent. I mean, all the data support the fact that the trabecular smooth muscle content and contractility is very important. So what you're seeing in this slide here, the control animals, this is Mason trichrome staining, they are stained pink. If you castrate the animals, which is labeled V here, treated with vehicle, is you can see the smooth muscle content decrease substantially. If you treat the castrated group 2 weeks or 4 weeks after castration with testosterone, you restore almost 90% of the trabecular smooth muscle. However, if you treat with estradiol, which is not a testosterone, it's just another steroid, you can see that you don't restore it. That means this is very specific to testosterone. If we do quantitation, we do histomorphometric quantitation, you can see the control, there's no decrease in the trabecular smooth muscle, but by castration, there is considerable decrease, like about 23 to 25% decrease in the trabecular. If you give estradiol, you do not restore, but if you give testosterone, you restore it almost to about 80 or 90%. What we run into, a unique observation, is that in the castrated animal, we see quite a bit of adipocytes or fat cells in the interface between the tunica albuginea and the corpus cavernosa. And this suggests that testosterone deprivation or testosterone regulates the biogenesis as well as the differentiation of the trabecular smooth muscle and the fibroblast. And by deprivation of testosterone, you switch to a different pathway, which results, instead of promoting differentiation to smooth muscle, you differentiate into adipocytes. You say, does this have any meaningful effect? It may, when we start talking about the veno-occlusive mechanism and the ability of the tissue to expand, and so it might be very, very important. The last thing I want to point out is that testosterone is really important for maintaining veno-occlusive function, and this is the model that Dr. Krane, Dr. Goldstein, and Dr. Tejada has proposed early, and they put some background to what might be. And what you're looking here is in the intact animal, the intracavernosal pressure looks normal. Upon castration, you can see that the intracavernosal pressure is diminished considerably. If you treat those castrated animals with testosterone, you restore the intracavernosal pressure, means the system regained its integrity and is functioning as intact. Treating with estradiol does not restore intracavernosal pressure. So what does that mean? It means that in absence of testosterone, the trabecular smooth muscle decreases because they undergo apoptosis and die, and therefore the tissue lacks the ability to expand fully to veno-occlude, and the result is veno-occlusive dysfunction. This is data from Dr. Ronald Willis group, and you can see that the castrated animals have a greater need to keep an intracavernosal pressure roughly of 60 millimeter mercury. You need to infuse far more volume than in the intact or in the testosterone treated, suggesting that testosterone is critical for maintaining veno-occlusive function, and testosterone deficiency can contribute to veno-occlusive dysfunction and venous leakage. Dr. Tom Liu group also demonstrated that in the animal model, that testosterone is really a prerequisite or required for maintaining the veno-occlusive function. This is a landmark slide from Dr. Goldstein group from Boston, and this slide tells us that the higher the smooth muscle content you have, the trabecular smooth muscle content, the smaller the volume needed to maintain erection. But the fewer smooth muscle content you have, the trabecular smooth muscle, the more volume you need. And this is from a clinical study, but this supports the physiological study in the animal model that atrophy and apoptosis and death of the trabecular smooth muscle results in veno-occlusive dysfunction. So to summarize, I only have a couple of minutes to summarize that testosterone is very, very critical in maintaining the physiology of erection, and it does it through various molecular components, specifically the nitric oxide pathway system, as well as the phosphodiesterase type 5 system, and maintaining the structural integrity of the corpus cavernosa, the trabecular, the connective tissue matrix, the nerve network fiber, and also inhibiting the adipogenesis. I would like to take 30 seconds to give really, really brief tribute to this honorable man, Dr. Robert Krane. Not only he's an outstanding clinician scientist, he also a great mentor, and many of you who have crossed paths with him would have recognized that. My interaction with him over a decade and a half, he's a very passionate about clinical and basic science research in urology and as well as sexual medicine. And for him to call me and ask me to come and take the directorship of the Urology Research Laboratory gave me the hope that this is the kind of people we hope we have one too many of them, but unfortunately we don't. He's an innovator. He has a spirit and a pioneering spirit. He's a caring physician, an outstanding teacher. And many of you who probably met him or heard him speak or talked to him, you would have recognized that. I would have to say, and this is not for me to say much about it, he's a leader. He's a prominent leader in the field of urology, and he's well recognized. Unfortunately, he was taken away too early from us. Thank you.